5 fan myths sound plausible because each borrows one true fragment and drops its conditions. This guide uses 5 bounded counterexamples, not product sizing or repair advice. Always define fan type, speed, air density, pressure basis, connected system, measurement method, and safety state before comparing performance. Myth 1 says a fan has one airflow rating. In reality, a fan curve and the connected system resistance curve intersect at an operating point. The same fan can deliver different flow when a filter, coil, duct, grill, bend, damper, or poor inlet condition changes the resistance. A free air value and a pressure-rated value are different evidence. Static, velocity, and total pressure are not interchangeable, and density, test setup, and measurement plane matter. Compare certified data on the same basis, then account for installation system effect rather than calling a mismatched field reading proof. Myth 2 says more RPM, watts, current, or noise always means more useful airflow. Different impellers, housings, diameters, motors, drives, and systems can produce different flow and pressure at the same RPM. Current alone is not input power, and input power is not aerodynamic output. Sound is not an airflow meter. Turbulence, tonal content, obstructions, vibration, distance, room reflections, and background noise can make a weak installation sound louder. Sound power and room sound pressure are different quantities. Useful comparison requires matched methods and operating points. Myth 3 says the fan laws predict every modification exactly. Affinity relationships describe constrained similarity, geometrically similar operation, defined density, appropriate speed range, and unchanged system assumptions. Arbitrary blade changes, diameter trims, Reynolds effects, compressibility, or motor and drive limits can break the shortcut. Even the familiar speed-cubed power relationship is not a guaranteed utility saving. Total input includes motor, drive, and control losses, while the installed operating point moves with the system. Validate changes against manufacturer or certified data and matched measurements of airflow, pressure, and total input power. Myth 4 says 2 fans simply double the result. Parallel curves add flow at common pressure, series curves add pressure at common flow. The connected system still selects the operating point, and unequal branches, interaction, unstable regions, backflow, and isolation can prevent arithmetic multiplication. Fan count also does not prove redundancy. A stopped or failed path may leak or freewheel, and remaining fans may hit speed, power, thermal, acoustic, or stability limits. Demonstrate the required duty under the approved failure case instead of labeling one extra fan as automatic N+1 capacity. Myth 5 says a small, stopped, or guarded-looking fan is safe to touch. Fans can coast, restart automatically, windmill, receive energy from multiple sources, or generate voltage. A software stop on a stationary will do not establish isolation, and size does not remove pinch, cut, electrical, or stored energy hazards. Inspection and cleaning follow manufacturer instructions and the applicable energy control process. Identify all sources, lock and tag where required, discharge stored energy, verify zero energy and zero rotation, maintain effective guarding, and restore guards before operation. Never reach through an opening or bypass protection for a demonstration. The practical rule is simple: define the duty point, compare evidence on a common basis, respect similarity limits, evaluate fan and system interaction, and control hazardous energy. Visible air movement does not prove ventilation or indoor air quality, and a general fan does not substitute for smoke, hazardous, grease, combustion air, or other regulated service.